We've developed a shortcut formula for finding these sums. Let's use it. It's all about putting the right things in the right spots. So just a reminder, the sum of the first n terms of a geometric series is the first term times 1 minus common ratio to the power of n over 1 minus common ratio. So if you're given that information, just plug it and chug it. Put the numbers where they go. So the sum of these first 10 terms is going to be 1 times 1 minus negative 4 to the power of 10 over 1 minus negative 4. Notice how I'm putting that negative number in parentheses. You need to. If you don't, you are occasionally going to have problems. So put that negative number in parentheses. I'm going to pull up my Desmos here. And what do we have? I've got the first term times 1 minus that common ratio in parentheses because it's negative to the power of 10, and then divided by 1 minus that common ratio in parentheses. So notice because the ratio is negative this time, our terms are actually switching back and forth between being positive numbers and negative numbers. So a lot of them, when you add together, are canceling out. That's why this final result, though it's big, is not astronomically large. So negative 209,715, negative 209,715. There you go. And just take a moment. Isn't that a whole lot quicker than actually multiplying out? Okay, well, the first term is 1, and then the second term is going to be negative 4, and the next term is positive 16, and the next term is negative 64. And doing that 10 times and adding them all up? I think so. Next up, let's do, starting with 80, multiplying by a half, sum of the first 9 terms. Sum of those 9 terms. First term, 1 minus common ratio to the power of n. Again, if it's a fraction, put it in parentheses. You know what? Just put it in parentheses all the time. That way you're never going to make a mistake. Now, you'll notice as soon as I said that down here, I didn't put it in parentheses. You can still do it. I recommend just doing it all the time. So let's come back here, and I'm going to take advantage of the fact that I've kind of already got the structure set up. I just want to change what the first term is. I want to change what the common ratio is. And how many terms are we adding up? I've already forgotten. The first 9 terms. Change that 10 to a 9. There we go. The decimal's fine as far as I'm concerned. I'm going to write it as a fraction as well. So 2555 over 16. And then as a decimal, 2555 over 16 is that 159.6875. Good and nice. All right. Well, what about cases where they don't just straight up tell you what the first term is and what the common ratio is and how many terms you're supposed to add? What if it's written in the summation notation? The first thing you need to do is recognize the setup. A geometric series will always look like first term times common ratio to the n minus 1 or I minus 1 or k minus 1, but it'll have this setup. So number times number to power. Notice how all of these fit that pattern. Here, there's a little imaginary 1 times. So it's like 1 times negative 4 to the n minus 1. If you recognize that pattern, which I expect you to be able to do, then you know this is geometric. We can apply our shortcut formula. If your index starts at 1, which, hey, look, all these indices start at 1, then your n, your number of terms, that's just this upper limit on the summation notation. Based on this description of the formula, here is your first term. And based on the description of the formula, there is your common ratio. So all the information you need is right there for you. So here, the sum of the first 7 terms is the first term times 1 minus 4 to the 7th over 1 minus 4. think I'll use, let's use the handheld this time just for something different. So first term, which I've already forgotten. So -4, 1 minus 4 to the 7th, all right. So -4, parentheses, 1 minus, and just for, it's a good habit, I'm going to put that common ratio in parentheses, even though it wouldn't be necessary this time since that's a positive whole number. Not a bad idea to have it there. And then dividing by 1 minus that common ratio. It is super important that you put that 1 minus 4 in its own set of parentheses. Otherwise, you're not going to get what you want. Let's see where we end up. Negative 21,844. So just for space reasons, I'm going to write it down here. Negative 21,844. That wasn't a highlighter. Not at all. That's not a highlighter either. This is going well. Tell you what, I'm going to get rid of whatever that is. I'm going to get rid of this black line that's there. We're going to see if we can, for a third time, switch it over to a highlighter. There we go. And also, I didn't highlight this one. I'm going to give that a highlight. All right, next up, if you haven't already tried this next one, go ahead and try it. It's all about finding the right stuff. So, first 10 terms, there's your n. A1 in the front, r in the parentheses with the exponent. Now you can do kind of the same Desmos trick where you don't have to retype everything. If I press second enter, it brings back the previous line that you typed in. So change the 4 to a 1/2. Now it gets a little tricky up here because, so if I delete the 4 by pressing this delete key, your calculator is conditioned to type over what you already have there. So if I now type in 1 divided by 2, it's going to cover up the parenthesis and the 7, which isn't what I want. I want to just fill in the parentheses. So above the delete key, you see it says INS. That stands for insert. So press second delete, and now I can just type the 1/2 in, and it will move things down and insert that 1/2 in the missing spot there. Okay, and I wanted to go to the 10th, right? Forgive me again, I gotta double check. Yeah, to the 10th, and then the first term was a -20. So back here to the front, delete the 4, but I want to insert the 20, and there we are. Woo! Let's see, does this make a nice fraction? Kind of. So -51/15 over 128. -51/15 over 128. And as a decimal, it's not pretty, but here's the thing. I really do need you and want you to write out all those decimal spots. It makes a difference. So -39.9609375. I think our shortcut formula here was probably a lot easier than trying to do all that by hand. And lastly, with this final summation notation, let's see what we got. It's 10 terms. The first term, now there was no number written in front as the multiplier. That means we need to know it was a 1. 1 minus the common ratio, that's the number that has the exponent on it, to the power of 10 over 1 minus that common ratio. I'm going to hop back over to I think Desmos for this one. My first term was 1. Change that common ratio to a -4. The number of terms to a 10. And down below, also that common ratio to a -4. So -209,715. Did we do that exact same thing earlier? We did that exact same thing earlier. Look at that. Well, nice to know that we can represent that in 2 different ways. So -209,715. So the takeaways. I need you to recognize the structure If it's number times number to power, that's a geometric series. Use our shortcut formula, put the numbers where they go, number of terms from the top of the summation, A1 is the front, and then the common ratio, that number that has the exponent.